Hi guys, and welcome to your next lesson. And in this lesson we're going to be covering units, which is part of our data representation unit that we did. Right, so you need a sort of initial understanding of all the different unit measurements, and these range from the smallest, which is a bit, and a bit is just either a 1 or a 0. A nibble, which is a sequence of 4 binary bits together, and nibbles are good for or useful for converting into hexadecimal, as they only use 4 binary digits. A byte, which is a typical sort of measurement, a common measurement, which is a sequence of 8 binary bits. And then the sort of more familiar kilobyte, megabyte, gigabyte, terabyte, and petabyte. Okay, now today I need you to start to begin to analyze the capacity for the various units for measuring data. So that is your kilobyte, megabyte, gigabyte, so on and so forth. Examining how to calculate file sizes, suggesting appropriate means of storage media, and then working at the difference between the uppercase B used in kilobyte and the lowercase b, which is used in kilobit. And then referencing this when downloading and storing data. Right, so I'm going to allow you to just go through these slides. It kind of gives you the basics of them. I'm only going up to byte because I want you to do some internet research into those. Now, I'm going to go through this one, which is a kilobyte. Now, the word kilo is what we call a prefix, and it's a prefix which is part of the decimal metric system. For instance, if we reference a kilometre, a kilogram, it's part of our sort of standard decimal unit of measure that we typically use. And kilo typically means a multiplication by 1,000. So we are representing 1,000 when we say kilobyte. Now, with a kilobyte is written or expressed as a capital K and capital B, and this is really important that we understand the difference, that we are referencing a kilobyte as KB and capitals. Now, second to that, this is a kilobyte can be thought of as 1,000 bytes. So bytes is the previous unit of measure, and that is typical all the way through. So the previous unit of measure is normally 1,000 going to a kilobyte. So the next one from this one would be a megabyte. So this would be 1,000 kilobytes in 1 megabyte. But it's the same process going through. Now a kilobyte can be thought of as 1,000 bytes. Now this is if we use our metric system, our decimal metric system. However, the computer doesn't see things in metric. The computer sees things as binary, and binary is to the power of 2. So this metric system is based on what we call a base 10 number system, which is our numbers. Whereas the computer sees it as a base 2 because it only has 2 numbers, 1 or 0. So the computer would see this as 1,024 bytes and not 1,000 bytes. However, because we're dealing with ourselves, human beings, and in reference to the exam papers, we can reference that 1,024 that the computer sees as 1,000. The sort of throughout the following slides, you'll see that there's some examples of the type of files that you could expect to see within this type of file size. So within a kilobyte, you would expect to see half a page of unformatted text, perhaps an icon, a short email, or a small button image like a thumbnail image of some sort. I'm going to leave you to go through the rest of these guys because it's pretty much the same process, and it should really be self-explanatory by now. So I'm going to scroll down to this part here. Now, when we are converting numbers from gigabyte to megabyte or vice versa, megabyte to gigabyte, this is kind of a standard sort of way of calculating. If I wanted to calculate a gigabyte down to a megabyte, what I'm going to be doing is I'm going to be multiplying this number by 1,000. Now you'll see that there, in this image it says 24. This is the computer's way of seeing it. but we're just going to use 1,000. So wherever you see 1,024, we can just use 1,000. So for instance, if I have 1 gigabyte, if I just grab my calculator here, if I have 1 gigabyte, what I'm going to do, if I want to represent this as megabytes, I'm going to multiply this by 1,000. So I'm going to multiply by 1,000, and I get 1,000, which is 1,000 megabytes into 1 gigabyte. If I wanted to represent this in kilobytes, I'm going to repeat the process, multiply it by 1,000. So multiply by 1,000 until we get 1,000,000. So there are 1,000,000 kilobytes in 1 gigabyte. And again, just reverse process if we wanted to go from kilobytes into megabytes into gigabytes. Only this time we're going to divide it as opposed to multiply. So I'm going to divide by 1,000. That gives us 1,000 megabytes. And then I'm going to divide again by 1,000. And we have our 1 gigabyte. So that's a very simple way of looking at converting from one unit of measure to the next unit of measure. So for instance, in an exam question, you may say, get a question say, we need to represent gigabytes into gigabytes. You just got to realize that you are multiplying by 1,000 twice because it's the second one down. Put a little table here, guys, for you, the way you can actually see the metric calculations and the binary calculations in terms of powers. Don't get too wrapped up in these powers, guys. This is coming in the next PowerPoint. I just wanted to see that so you can come back and reference this. There is an activity here for you to follow, guys. I want you to actually do these on paper. Use a calculator by all means. And, although I'm asking you to use a calculator now, there are no calculators allowed in the exam papers. So initially use a calculator, and then obviously then you can do the math in your head. It's not in your head, but you can use paper to do the math and they'll work that out. If for exam purposes, that's actually advantageous. We can actually then see how you've worked it out. Okay, so I want to ask you to then now pause the video and just do the two conversions to 2 units below and 2 units above. So for megabytes, we're going to go down to kilobytes and then bytes, and then from megabytes, we're going to go to, megabytes down to kilobytes and bytes, and then gigabytes and terabytes, and do the rest for the same. There is just thinking about conversion. Yeah, okay. So I'm going to go through this part as well. So this is another way of looking at conversion. So for instance, if I wanted to convert this into megabytes, and this isn't a way to think about it in your head. I already know that 4.7 gig, that 4 represents the gig, and there are 700 megabytes in there. So I want to separate these out. 700 meg, 4 gig. Again, I'm going to follow that same process here to get that 4 gig down to megabytes. Okay, so I'm going to multiply it by 1,000, and that gives me 4,000 megabytes. If I add them together, there's my 4,700 megabytes. So we're going to convert this into kilobytes and bytes, and you need to be able to show you working out. Now it doesn't matter that I've given you the answer here. I want you to do it on paper yourselves. Okay, so this is a potential answer, a way that you could think about it. There are a couple of ways to do this in an exam. So we've got 4,700 megs. So we're going to be multiplying this number by 1,000, and that gives us 47 million kilobytes. Then we multiply it by 1,000 again, and each time it goes down, all we're doing is we are adding 3 zeros on the end. So every time we go down to a lower unit of measure, we're adding 3 zeros to the right hand side of this number each time. So there is a pattern. I'd like you to carry out activity 2, guys. This one giving you MP3s. So there's 3,000 MP3s at 3 mega file. Need you to calculate how many of these you could fit onto these particular storage media. And I want to carry how many typical size movies, 1.5, could you fit onto a 1 terabyte external drive, and how many characters would there be in an email with a 2 kilobyte file size. Okay, activity 3 is suggesting appropriate media for these particular files. So your group 1 of files is here. So notice now how we're using different units of measure, so you're going to have to calculate these down, and then what I would like you to do then is I want you to then suggest, once you've got the correct answer, the correct number, suggest me a suitable type of media to store these on. Do the same thing with this line, and then do the same thing with these 4 types of files. Lots and lots of different types for you to get on with. By all means, if you manage this one, guys, you know, you can just make up your own and just have a go with the numbers. The last slide on here has got some calculators, so you can use calculators just to check your answers, and obviously make sure you're getting those right. Remember, any questions, guys, just blast them through, share my homework.